Continue with these notes on finding area and perimeter with incomplete information. So on these next handful of shapes, it's just one page of shapes here, but each of these has missing pieces, and in those missing pieces we need to figure out what it is or how to get it, and that will then help us calculate the total perimeter, total area. So when I look at this first triangle, I notice that I have a hypotenuse and I have one of the legs. But in order to calculate the perimeter, I need all three. And also, in order to calculate the area, I need a base and height that are perpendicular to each other. So I'm going to say that my missing piece is the horizontal leg. And in order to calculate it, again, I can use these calculators that have to do with Pythagorean theorem, area of a kite, or area of a triangle. In this case, I think Pythagorean theorem is going to be most useful. And instead of calculating the hypotenuse, I'm going to change it to one of the legs. I'll say leg B, the horizontal one down on the bottom. So if the hypotenuse is 9 and the other leg is 7, there we go. The bottom horizontal leg is 5.66. So I will screen capture this. And paste it in there. I'm also going to go in and edit this picture, adding in the information that we have. So this bottom piece down here is 5.66. Again, I'll make that a little bit bigger in my text, just so it shows up more easily in the drawing. So that's 5.66. Now the perimeter then is going to be a just sum of those things. And if I want to use math.new as a real basic calculator, I could say 7 plus 9 plus 5.66. And that gives me a total of 21.66. And there's my perimeter calculation. It's that easy. So I'll capture that, put it in for my perimeter. And now for the area. The area is going to be these two legs multiplied by each other. And it's asking me for the height times the base. And in this case, the base is 5.66. And the height is 7. It says the area is about 19.81. So these, when you're using tools, it can go quickly, but you have to know what to type in for your tools, and that's kind of the key move with all of these. Okay, let's take a look at this picture here. Now, when I see this one, I have multiple numbers, but I need to keep in mind that this 13 is only for that measure right there. And I still need to figure out what's this leftover measure. Well, it happens to be the triangle that we just found with 7 and 9. And if you remember, that calculation was 5.66. So right here, I'm going to add a text box just saying 5.66. We'll make it bigger. There we go. And so now I have that distance, 5.66, and this distance, 13. I do need to put those two things together. So I need to say 13 plus 5.66 to get a total of 18.66. So if I wanted to calculate the full distance from left to right, that is 18.66. Let's copy and paste this text box and we'll put it down here. Say 18.66. Awesome. So it's all the way across as 18.66. So what were we missing here? We were missing part of the base. And we did the same calculation as before with the Pythagorean theorem to calculate that missing part of the base. Now let's do perimeter. So, we're missing more than one thing. So we're missing part of the base. And we're also missing this other diagonal here. So let's calculate that. That would be, we are calculating the hypotenuse, and it's going to be 7 for one of them and 13 for the other. And that shows me that the hypotenuse is about 14.76. So I can copy that. Put this in here. It's 14.76. So then when I'm going to calculate the total perimeter, part of the base, and one of the hypotenuse measures. And you don't have to screenshot every single piece of your work, but it's helpful to kind of know where we're finding each of these calculations. To calculate that perimeter, I got to add those numbers together. So I have 14.76 plus 9 plus 18.66. There we go. And that total is 42.42. So I'll screenshot that, capture it, put it in here. For the area, we're looking for the height, which is 7, times the total base, 18.66. So again, it's a triangle like this. The height is 7, but the total base is 18.66. And that's going to give me an area of 65.31. I'm just going to screenshot just this bottom piece down here. Save a little bit of space. There we go. All right, now let's look at all these kite and rhombus shapes. So for this first one, I have RM equals 9. I'm going to actually add that to this piece here. So I'm going to say this is 9 for that little measure. The thing about a rhombus is it has a folding symmetry. So this 9 is not only RM, it's also the same as PM. And it says SQ is 24. So if the whole thing is 24, that means that this half over here is 12. And this half over here is also 12. So I have 12 and 12, 9 and 9. So I have pieces in there, but what I'm missing, it looks like, is these outside edges. And I might need those. So we can do a Pythagorean theorem because this is a rhombus, and that means it makes 4 right triangles. And for one of the legs, we have 9, and for the other leg, we have 12. And that gives me a very exact answer of 15. Comes from a 3, 4, 5 triangle. So I'm going to put text box here on this edge, say that that's 15, make it a little bit bigger. And the neat thing about it is that that 15 is the same measure all the way around. That's what these little tick marks mean, these little kind of perpendicular slashes. They're saying all 4 of those are equal. So it's 15, 15, 15, 15. So what were we missing? We were missing PM, which was the other half of a diagonal. And we needed the hypotenuse edges. Okay, so how do we calculate these things? Well, one, let's make this a little bit smaller. It doesn't need to be quite that big. Oh, that is already pretty small. There we go. But for the perimeter, now that we have all of those pieces, we're going to do a couple of calculations. One, I'm going to capture this calculation And then I'm also going to say that the perimeter is 4 times that 15, which you might just do as mental math, but 4 times 15 is in fact equal to 60, because I have 4 side edges, all of them 15. Make that smaller, keep it inside the square. Now that was for the perimeter. For the area of a kite, we're looking to multiply the 2 diagonals. A rhombus and a kite have that same kind of calculation. So I have 12 and 12, so one diagonal is 24. 9 and 9, the other diagonal is 18. So it's just 18 by 24, and that gives me an area of 216. We'll screen capture just that little piece there. Now we have that area. All right, let's finish out with these last 2 examples here. Very similar to what we did before, but let's notice what's kind of a little bit different this time. So it says SU is 24, so all the way across here is 24. I'm going to go ahead and split that into 2 halves. If the whole thing's 24, each half is 12. So that's 12, and that's 12. And then it tells me that RU is 20, which is helpful because now I have one of the hypotenuse diagonals. Because it's a rhombus, I actually can apply that, copy and paste it, to all the other ones as well. So 20, 20, 20, 20. What I don't have is TR, but I notice that I have a triangle here where I could find TR or KR. So in this case, let's make that a little bit more see-through just by fading this out. So we're looking for that like faded blue edge here, KR. And in order to solve for one of the legs, we're going to use Pythagorean theorem. But we will solve for that bottom leg, which in this case is leg B. And that means I'm going to have one of the legs is 12 and the other leg is 20. That gives me a measure of 16. So I'll capture that. And I'm also going to put this little piece in here. Let's duplicate it. One of these. That's 16. And if that's 16, so is this other side. So we just had a lot of stuff going on. What did we not have? We needed KR and TK, or both put together, which is TR. And the way that we calculated those was with that Pythagorean theorem calculator. All right, now for the perimeter, it's just going to be 20 times 4, which again, very easy to do as mental math, but it's always fine to double check with a digital calculator. 20 times 4, we'll put that in here. That's going to be equal to 80. That's for the perimeter because it's going all the way around this rhombus. For the area, we're going to take those 2 diagonals. It's going to be those, but then cut in half. So we multiply those and then cut in half. So one of the diagonals, the up and down one, is 24, and the other one is 16 and 16, which makes 32. And that gives me a total area of 384. Awesome, awesome, awesome. All right, now this kite, this is probably the most complex because it doesn't have the same symmetry as a rhombus, but it has enough pieces that we can put things together. So let's start out with FH equals 48. Well, that tells me if this top to bottom is 48, a kite has a symmetry where the top and bottom in this case will fold into itself. So I can say that this piece here is 24, which is half of that 48. do the same for that one. So that's 24 down there. It says that EH is 26. So I'm going to duplicate that number just so I can put it there. EH is 26, and it has a double slash mark on it. So that means that this EF is also 26. But HG or GH and GF or FG, this other side is not the same. That's important to know. All right, now it tells us that the whole thing EG is 23. And it wants us to find GD there. Well, that's got a couple of problems going on with it. The first is that we have a right triangle here in this corner. And that right triangle we can use to find ED. Once we find ED, then we are able to do a calculation to find the rest of it. Knowing that the whole thing is 23, we can figure out what this leftover is going to be. All right, so let's do a Pythagorean calculation with the hypotenuse of 26 and a leg of 24. And that gives us that this length here is going to be 10. So I'm going to take a text box, add it right there, and that's 10. But if that part is 10, then what is this side going to be? Well, the whole thing is 23. This side is 10. So I got to find a number that's going to add up to 23. And in this case, it's 13. All right, now that gives me another thing that I can do, because now I have another triangle. We'll throw in the shape here. Kind of makes that shape there. I'll flip it around. So I'm going to rotate, flip it horizontally. And I'm going to use Control and the down arrow to kind of shift it underneath that 13. You know what? In fact, I'm going to make it fade out. So I'm going to use a transparent color again. So if I go and I change the color, add a custom color, make it transparent, now I can see some of the pieces. Why that's helpful is I see that I have the 13 and the 24. And those are two edges on the right triangle. The only edge I'm missing is the hypotenuse. So if one of my legs is 24 and the other one is 13, that tells me this leg out here is 27.29. So we're going to capture that calculation because we'll paste it into our work. So now I have some calculations in here. The other one that we did was 26 and 10. Or 26 and 24. That was when we had 24 and 26. So what things were we solving for? We were finding part of the diagonal, and also the hypotenuse HG and GF. Awesome. Now how do I find the perimeter? Oh, we didn't mark it on here, so let's add that in just for a moment. Then we had 27.29 for that edge. So in here, this is 27.29. Make that a little bit larger. Awesome. So is this side. So now we have measures all over the place. To find the perimeter, I have to calculate all these outside edges put together. So I'm going to say 26 plus 26 plus 27.29 plus 27.29. It's just a bunch of adding, and eventually we get to 106.58. For the area, I'm going to multiply those diagonals. So those diagonals were 23 for EG and 48 for FH. So let's do area of a kite. We had 23 and 48. That gives me a total area of 552. So again, use the calculators, use the tools, but know which pieces you need to find the in-between measurements so that you can set up your perimeter totals and your area calculations.